up, YouTube? Today we are going to be discussing 10 tips that can help to improve your AWS account security posture. Let's jump right in. Tip number 1. Ensure that you use accurate account information. So when AWS needs to contact you about your account, the information defined in the management console is what's used. You want to ensure that that information is current and up to date. So if you have an email address or a phone number that may have changed, you want to keep that as up to date as possible. A second tip here is to, instead of using a single email address associated with that account, see if you can set up an alias for that email address. That way, it'll just go to that alias and not to a single person. So the alias could end up pointing to a distribution list or something on the back end. But you just want to make sure you don't have a single point of failure here with a single person's email address. Tip number 2, use MFA. If you don't know, MFA stands for multi-factor authentication. And this helps to safeguard your account. There's several different MFA providers out there, or options for MFA. Some you can use a virtual MFA. Some use a KeyPass. Some use a key fob. But there's several different options out there. But rule number 1 would be, if you haven't done this yet, is to make sure you have MFA set up on your root user account. Obviously, you don't want to use a root user account except for to just manage things at a higher level. So you really shouldn't be logging into the root account much. But if you, in any case, make sure you have MFA enabled on that account, and then any additional IAM accounts that are set up under your organization, you want to make sure those have MFA enabled also. So there's a way you can enforce MFA when an account gets created. So what I typically do as part of a account setup process, I'll create the account, and then there's a checkbox that says force this user to change their password on the next logon, and then there's another checkbox that says enforce MFA on this account. So always turn those 2 things on. It'll help you in the long run, safeguards from your account being hacked. So that's rule number 2, or tip number 2. Tip number 3 is never store AWS API keys or secrets in your source code. So you can use the AWS Secret Manager to control information in your application. Users and applications can retrieve secrets with a call to the Secrets Manager API. So if you've been on the internet for any length of time, you're familiar with data breaches and hacks of some of these organizations. Some of those are done from bad configurations in the cloud, but also a large amount of those are done because an API key was stored in the source code, and that source code could have gotten uploaded to, or may have been uploaded to a site like GitHub or some public repository, even though the repo itself may not have been public, but there's ways that people can access these things. So just a rule of thumb, make sure you don't store any of those secrets in your source code. So Secrets Manager is definitely the way to go. You can just make a call to the API, and it'll retrieve your values that are stored there, and your application will function just fine. Tip number 4 is to limit your security groups. So here we are saying that ensure only the required ports and connections are enabled. And then 2, you can use AWS Config or AWS Firewall Manager to programmatically ensure that your VPC is configured properly. So this just goes to say that kind of along the lines of least rule of privilege, or least access of privilege. So your security groups should only be able to access what's required for them to do their specific role or job, whatever that looks like. And that's specific to your organization. So you wouldn't want to have just like this general security group that can access everything. You would want to have it basically very granular and tight as to this security group can only access this resource, or this security group can only access this port on this VPC, things of that nature. But you want to keep it as tight as possible. Tip number 5 is to implement strict data governance policies. So one way to do this is basically you want to start with classifying your data as public versus private. Only you would know that as it pertains to your application or whatever services you're building on the cloud. Another big thing, and I actually have a separate video about this, is to block public access from S3. So as we know, just about anything can be stored on the S3 bucket. Not anything, but several things that can be stored on the S3 bucket. And several of those things could contain PHI. So one of the easy things to do is just go in there and say, hey, let's block the block public access from this S3 bucket. And that's one additional step to take to ensure your buckets aren't accessible. And then the next thing here is use different IAM roles for encryption and decryption. So this is pretty much saying that you may have one role that's ingressing the data, and it could be encrypting it, and then another role on the egress could be as part of that role, it could be to decrypt the data. So that's just saying you want to keep those roles separate if you can, and it goes a long way as far as having and implementing strict data governance policies. All right, tip number 6 is to centralize your CloudTrail logs. So just from AWS, they recommend that you write CloudTrail logs to a designated S3 bucket with a dedicated account. So obviously, as we said before, this S3 bucket would obviously you want to block public access to this particular S3 bucket. Also, you can go in and ensure that the permissions on the bucket don't allow for any deletion of the logs. So this is just saying that if for some reason I was storing my logs here, but I still had delete permission enabled on that bucket, that kind of defeats the purpose if I can't even go back and look at the logs if someone's allowed to go in and delete the logs. And then also you want to encrypt those logs at rest. Tip number 7 is, this is pretty simple, validate your IAM roles. So you can, AWS has several utilities out there, but one that I'll do an additional video on is IAM Access Analyzer. And basically, you can use this to review access to your AWS resources. So basically, you can take this tool to see if certain roles or permissions that you thought didn't have access to a resource actually have access. And this is a way to help kind of clean some of that stuff up. So probably very beneficial to you. Rule number 8. So basically, tip number 8. Basically, take any actions on your findings. So what you can do here is you can classify your findings based on severity. So I have just a quick breakdown: low, medium, or high. Once you have your findings classified, you will have a better way to triage your findings. Some things may or may not require immediate action, while others may, and you pretty much have to use your own discernment and consult others in your organization if needed. So this could be if you found a API key that was in several places in your source code and you thought it was removed or you didn't think it was actually there. So to me, I would classify that as a high severity. We basically need to rip that out, implement a security manager, and redeploy that particular piece of code or several projects that have that reference to those keys in it, because that's a real easy way for you to get exploited. So just take that into consideration. Rule number 9 or tip number 9 is to rotate your access keys. So basically you would want to go in and a good rule of thumb here is to rotate any keys that are greater than 90 days old. So basically you can just go in to your IAM account and basically say, hey, are there any access keys on these user accounts that are greater than 90 days? Or that's one check. Another check could be if there's a access key that's just kind of stale or stagnant that may not have been used in the past 90 days or maybe even 60 days for that point. You would just want to go in and disable that access key. If someone's using it, which if they haven't been using it in 60 days, they're probably not using it. But once they turn it on and they try to reuse those keys again, they'll get denied because you've restricted their access to the platform via the keys. So that's an easy one there. And then finally, number 10 is to get involved in the development cycle. So this goes as far as raise the security culture of your organization, be an advocate for best practices. As we know from the shared responsibility model, that security is everyone's job. So I believe, and I don't have the document up in front of me, but security of the cloud is a shared responsibility. So AWS is responsible for securing the resources in the cloud, as far as from like a physical standpoint or infrastructure standpoint. And then you as a consumer of AWS, you are responsible for securing the data in the cloud. So I'll do a follow-up video on the shared responsibility model, but not just, even though you may have a CISO at your organization, they're not going to be as entwined in the development process as you are. They're just kind of looking at things from a high level, maybe a 10,000 foot view. Whereas if you're a developer or you're on the dev team, you're looking at the code. You can see what's being done, and you could bounce ideas off of other counterparts in your organization or outside of your organization just to work towards using AWS's best practices when it comes to securing everything, and just not shooting yourself in the foot. So that's pretty much it. Like I said, those was 10 tips to help improve your AWS account security. If this video has been beneficial to you, please like, share, and subscribe to the channel. Thank you for watching.